bench, and we should be ready. Let the audio think in. This I can stop. Camera works. Audio seems to work. Audio works. USB works. Everything works. And we will continue. Let's zoom a tiny bit, although not too much because it's a huge setup. We'll continue a tiny bit with the battery. I thought I was finished. I wasn't actually. So this is an escooter battery someone found and gave it because it wasn't working. It wasn't enabled. There was no output. You can see on this voltmeter we have 26 volts output, which we measure with these two leads. But this is a 48 volt battery, meaning we don't have the full output. And as soon as we load it a tiny bit, it will drop dramatically. So this is just a leakage current. In the previous stream, we were playing with CAN because I thought this is how to activate it. In the end, it turns out that you just have to connect a sense wire to the output and then it activates. And meanwhile, I built this connector. This is using US plugs. So I'm not in the US, so I have plenty of US plugs which I never use. And just hot glue to hold all the US plugs and plug it in there. And what it will do is short this wire to this wire. This wire is the sense wire. This wire is the sense. This is the plus. This is ground. This is charge. And if I plug it in, you should see the output enable. Yeah, you see 53 volts. Well, you see it on the screen. I see it here. Meaning now we have output. And I thought I was finished. And we could use the output to do whatever we want. Turns out we can't. For example, if now you have plenty of resistors which are in series on the output of the battery. Now, if I connect it here on this one, it means we have two 10 ohms in series. We have 20 ohms. Actually, I should put it in watt. No, for now, it's not too important. Now we will have 40 volt in series. So on the second multimeter, you see will be the current, which will be measured. And this is what I connect here. So these on the battery, if I connect it here, we see we have 2.4 amps going through. And after a couple of seconds, between 5 and 10 seconds, it shuts down. We are just drawing 3 amps. Less than 3 amps and it shuts down. And this battery should be capable of a lot more because it's there to power an e-scooter. And that I didn't know in the beginning. And I was trying to power a high power motor with this transformer. This is a high voltage input, so up to 78 volt inputs. And then I can step it down to any voltage and it supports up to 600 watts. And when I would power a high power device, a high power motor, it was just switch off. I have nothing which is capable of using 50 volts, so I had to power it down. And I was wondering if this is the cause or the battery is. Well, as you see, it turns out the battery is. Now we have 0 volts and we have no output anymore. If I release it, it takes around 50 seconds. This is what I measure here. It takes about 50 seconds to recover. And this is the state that we are in, and I wanted to stream to continue it, to share my progress on it. So we don't need this anymore because we can already work on this. And this is not too warm because it's been enabled. And here you see, well, this is a bit faster now, but you see we have output again, we have 53 volts. And if we continue, if we replug it in, we won't have any power anymore after 10 seconds. So it can, but what it can do, if we continue, we have 1, 2, 3, 4, 5. Now we have 50 ohms with all the series. And if I connect to the 50 ohms, then we see we have a bit less than 1 ampere. 980 millivolts. And even after 5 seconds, it doesn't switch off. And it turns out that the battery is capable of delivering 1 ampere, around 1 ampere, continuously. And this is trying to get warm. For now, it's not warm, so it's okay. But it is getting warm. I will put it in a water afterwards. We have plenty of energy. So now we see more than 10 seconds and we still have more than 1 ampere flowing, around 1 ampere flowing. As soon as I do more than 1 ampere, if I plug it on here, so if I have 40 ohms instead of 50, it will shut down after 10 seconds. So the battery, the battery can deliver 1 ampere in this state. Now we also discovered that in the beginning we tried to unlock it using CAN, although it was only the other thing. Now only the other sense wires which need to be connected, but maybe it's both, and this is what I want to try. So I didn't have any CAN connected before. Now I connected CAN back. The battery is closed, and these two prongs which you see here are the CAN low and CAN high. This is a symmetric connector, so you can plug it on the other way. So on this we have CAN connected again, and what I wanted to try, and I didn't try it yet, is if I send a CAN message, can I draw more than 1 ampere? That's the question. But first, because these are power resistors, so 10 ohm each, and they should be able to withstand 50 watts. So that shouldn't be too much of a problem, but you still have to cool them. So for cooling them, I will simply put them in water, because water can have plenty of energy. Can store plenty of energy, and it's easy to cool. If it gets too warm, we just change the water. So that puts the resistor in water, and this way we can try with it. We can try to play. Here we have kind of a connection mangling. Let's have it this way. Crocodile clips with not too much quality. And this way, and this is even getting water. It's 50 volts, so it's not important if I put them in water. And this one is the last one, which I will connect to. And they won't short any between each other because the voltage is not high enough and the water is not too salty. So normally if I connect it again, we can actually test it. If I connect it again, we should only draw 1 ampere still. See, this is the this is water, this is a prong. If I just plug it in, oh, there is some current going through the water. 70 milliamp. I didn't expect that. Oh, and I see that here there's electrolysis happening. So that's fun. The teeny tiny bubbles, you won't be able to see it. They're really tiny. And if I connect on this, we have 1 ampere. Let's see if 1 ampere withstands it or if it shuts down after 5 seconds. But yes, there is some electrolysis happening on the thing. Yeah, 1 ampere. You see, this was really at the thing of 1 ampere. So this BMS, which is inside here, can really measure and say if it's more than 1 ampere, stop delivering any power after 5 seconds, because probably it's not completely activated. So what I want to try now is I connected this on CAN, but this module on CAN, which has the codes, but I don't know if it is actually connected correctly. So we will have to monitor it. Monitor, is it this one? Yeah, monitor. And the code on this one is able to send the codes, all the 29 codes, and it is also able to monitor on the CAN. So if get idea if that's done, monitor. No context. Okay, I know why it doesn't work. I think it's the master. Okay, it's monitoring, and if I share the screen, yeah, it's monitoring. So this is monitoring if they input, and we know that if it is charging, it should be outputting. So I don't know if I showed that already. Yeah, I think I did. When it is charging, it's outputting data. So here we have a charger. I received the charger meanwhile, and if I enable it, it should be charging. So on this connector, I also have the connector charger connected, which is this thing. It's a smaller connector because it's only 3 amps. And if I enable it, we should see some CAN messages after a while. And this would mean that, so now it's green, it's not enabled. After 10 seconds or so, the BMS should enable charging the battery. Okay, now it's charging the battery and we see CAN messages. This means that the connection is fine, which I'm quite surprised. And yeah, this is a bit flaky, so these are metal bars normally to open stuff, but I don't have the correct plugs to connect in here. Here I used US plugs. I don't know how they are called though. Well, things out of US plugs which I don't use, and I didn't have any more, so I used these things. And normally they should be, I don't know, 1 millimeter. It's 1 millimeter up to 1.8 millimeter tab board mounted boards. So CAN works. Now I want to try if there is an error. If it shuts down, does it tell it that there is an error? So let's try it out. Now CAN messages, output is enabled, and if I connect to it, we have output now. You see it also with the multimeters, and after a couple of seconds it switches off, and no, it doesn't report over CAN that there is no current. There's current, and it doesn't report that there's any current. Maybe we can request it over CAN to know how much is drawn, because it can clearly measure the amount of current, the current which is drawn. It stops after 1 amp, but I don't know the messages. So now what I will try to do is let the battery recover. We will send the messages, and for that I just need to press the button, this button. And then we will try if we can deliver more than 1 amp continuously, and for how long. The original code sends it every 500 milliseconds. I don't know if it's required or if it's just required once. We will see. Let's wait for the battery to recover. Takes around 50 seconds. You will see it with the voltage. As soon as the voltage goes at 58 volts, 53 volts, above 30, then we are recovered. Okay, 53 volts, we are recovered. If I press on the button, it says that it sent all the messages, and now if I connect it, does it actually do something? Does it work? Okay, well, we have more than 1 ampere. Maybe it's not enough to play it just once. But let's switch on the timer, and we are already above 10 seconds now. These are 8 seconds, and we're still delivering some power, and there's still some electrolysis in the water. That's fun to watch. Not sure if it's a good thing, but it's too much. It's like 50 watts. I can't cool 50 watts. Not sure if it's a good idea to have this in water. Would be good enough. And we're still drawing energy. So maybe we just need to send the messages once, and then it's completely... Although no, we did to the battery already a long time ago, because we debugged that. So let's wait 5 minutes, and maybe we need to send it every 5 minutes, or maybe just at the beginning to see if it stops. Oh, the water is getting some color. I don't think it's a good idea. It's getting yellow. Let's stop that. Thought it was a good idea, but the water is getting yellow. Ooh, this is weird. Let's move them out and let's cool them with air. This is the last one. At least it worked cooling it. They are not warm, but they are making some electrolysis, so it's not good. Maybe I have something else which I can put in water. Let's get this out. I'm not sure. Normally I should have the remote, which I can use with the remote to switch between the modes. I don't remember how to switch between the modes. this way. Okay. So I don't have to move. Yeah, okay. Do I have something else which I can put in water, which is around 50 ohms? Yeah, this water is yellow now. It was not yellow in the beginning, so I don't know what it gets, but there's some electrolysis which is happening. Not a good thing. I want to try though, so there's still some water. I want to try now that it's, if the code is still working, if you can still draw 1 amp continuously. So 1, 2, this gets here, this is here. We need to draw not here, but we need to draw here. And let's put it around this way. Input, output input, input, output input. Oh yeah, and some of the metals is getting corroded. Okay, so it wasn't a good idea. Let's connect it to this output. It should be 1 and 1 amp, and let's see if it can do it for more than 5 seconds. No, it doesn't. So it's every time before it takes a load that you should send the messages. So this is why it's sending it periodically. So whatever happens. Oh. Even the crocodile's clip are getting corroded. Tiny bit. I have plenty of other power resistors. And I have these ones. This is some heating wire. Maybe this is what we can use, which has more than 50 ohms. Let's try. I have 3. This one, the longer it is, the higher the resistance. That's for sure. So let's measure the resistance of this one. I have 3 of them. This is 400 ohms. Yeah, you don't see it. Up this way. Yeah, I only have 2 multimeters which are connected to my bench, so generally I don't use more than that. This is 400 ohms. I need something like 50 ohms, 40 ohms or 50 ohms. This is 200 ohms. Well, I'm holding it with the hand, so I'm tiny bit. Yeah, my 100 kilo ohms are in parallel, but I don't think this is significant. This is an order of magnitude, even 100 order of magnitudes. This is, yeah, 40 ohms. This should be fine. Let me change the water. So get some fresh water, because I'm not trusting this yellow water anymore. And this wire is definitely waterproof. This is in a silicone sleeve. It's very flexible. These are carbon meshes, and this is silicone proof, waterproof. So let's put this here. Let's put the heating wire in the water, just with the 2 leads outside. Oop. Lead, come here, and normally if I connect the 2 ends, we should also have something around 1 ohm. And then we can use it all the time. There's water everywhere. With plenty of electricity, I'm not sure if it's a good idea, but... So, this is one side. Up, and the other side is here, 2 times black. Who cares? Normally, if I connect it, we have 1.2 amps, and it's heating water, and we have plenty of water, and then it switches off. Perfect. So we will use this, but instead of clamping every time, I would like to have a connector or some kind of switch. That would be a lot easier to switch on and off instead of this. So what could I use? Switch on and off. I should have switches, DC button, plus switch, AC switch. I could use AC switch. The AC switch should be able to handle plenty of energy. or just a normal switch. Where's my switch box? Switch box. Up. Up. Yeah, something like this should be able to handle the load. This is it's not rated for DC, but it's how many amps? I don't see it here. 128 volts, but it doesn't say how many. 6 amps. I think it's probably 6 amps in AC and 4 amps in DC. Don't know, but that should be plenty sufficient, so we'll try that. This is maybe a bit weak to handle the 4 amps, although it is short. And the 1 amp. This is fine for 1 amp. So we'll build it this way. Or maybe directly here. No. Crocodile clip. One disc will also get warm, this wire. Maybe it will get wire with 1 amp. I hope this crocodile clip is enough. I don't have thick crocodile clips. I do, but I do here. Let's use this one. This and here, crocodile. These are leads from multimeters, and they should be able to carry 10 amps. Up, so this. Let's remove these resistors. Up. Then we have lost the switch. No, it's here. One side. Now let's put it to off. The other side, and if I switch on, we should see 1.2 amps. It's heating water. The water, and then it switches off. Okay, now we have on-off switch. Let me put this in water to this side because I have a space here. You can kind of see it. This has plenty of energy, and then we have the switch. And if I switch on, does it work? Oh, it's still off. We didn't wait enough time for it to recover. Okay, that's a good thing. Up. Up. It's easy to test this way. So, we know that using that we can power it. How long? I would like to test if we can power it over 5 minutes. So let's wait until it recovers. Actually, I don't need the overview, probably because this, because, well, there's nothing in there, so I can leave the overview. You can see all the tools. So we recovered. Let's enable it. Switch. Oh no, not enabling it. We have to send the codes first. Oh, we did receive some codes. Transmission complete. It did send some codes. When did it send? Did it send it? I don't know what they mean. Let me take a note. Is this when it was enabled and then disconnected? We'll have to figure it out. But let me just take the notes to know that these IDs are actually from the device. So I didn't show you here. After we send the messages, it sent this code, although we didn't charge it, and I thought it only sends when we're charging it. But here it did send some data. It's always null, so it's probably sending some status. I don't know. I also need to get some water from my throat. So there are some status information. Maybe it says when it starts to draw. Well, I don't know. We'll test it. So let's reset that. Let's send the code. Okay, it wasn't able to send the code. Okay, now it sent the codes. They have been all act. Let's want to wait. How long do the codes last? Let's wait 1 minute and see if I can still draw some power after 1 minute. "20 seconds. Let's switch back to this screen. 30 seconds. And here I have plenty of notes. And how long also can it will? So I did only started to figure out that it switches off things. Now we know switch on, but for how long? 50. Okay, 1 minute. Let's see if the codes are still working after 1 minute. We will send it periodically. We know that we need it. So, and then for how long? On, up. It draws 1.2 amps. Switches off. Okay, it doesn't last 1 minute. Activation window. Let's call it this way. Window less than 1 minute. Let's try with 60 seconds. And here it reported something again. Yeah. Did it report it when it was enabled or when it shut off? I want to try. Let's send the codes and then wait 30 seconds and test if it works after 30 seconds. Okay, we are sending the code. That's done. When the red LED is on, 30 seconds. When this red LED is on, it means that it sent the code. When this red LED is on, so now it's finished. It's not sending the code anymore. This red LED is on to say that it is on. The module is on. It would be blinking if there was an error, and we did get once before. So we're not sending codes anymore. Let's wait 30 seconds and see if there's still some activation. 30, switch on, and it didn't transmit the code. The device didn't transmit the code yet. You're not seeing it. And reset. After 30 seconds, it is still on. We are now above 10 seconds and power is still on. Okay, so it lasts between 30 and 60 seconds. Less than 1 minute and more than 30 seconds. I think it would probably be 1 minute. We did a bit more than 1 minute. So the codes last for 1 minute. We need to send them every minute. We can send them every second. So the bus is completely wide open. What would be interesting to know if which codes do the activation actually, because we have plenty of codes. We don't know which one are the right one. So let's wait until more than 1 minute. We know that the codes don't last for more than 1 minute. This is something is burning here. Yeah, the fibers are burning a tiny bit. I'll correct it afterwards. Oh, okay, now I switched it off. Oops. But, oh, this is getting discolored. Damn it. I'm getting the wires. I should probably not use crocodile clips for that, but something a bit more sturdy. So here water is getting off. And we can still sync. So the code is lasting for a bit longer. Yeah, the wire which is not in the water is getting... now it's switched off. So it doesn't last forever. It lasts less than 2 minutes. And we didn't switch it off, and it sent some code. So it after some time, when it switches off after activation, it's sending the code. So this code here, 004 means fault off. Noted. Switch off fault. Timeout. Switch off because timeout. We don't know. Timeout. Well, I'm not sure if it's useful to decode it. At least we know that that's the bit. Put this tiny bit more in water. Because if we send the code all the time, we probably don't require it. So let's try it again to see how long it stays activated. So send the codes. Codes are sent. Switch on. Switch this one on. Oh. We see that some wires are getting burnt. Here. I'm not sure if it's a good thing. Or is it water? No, it's not water. No, that's not a good idea. There is some burning happening here. There's a fire alarm. I have a fire alarm here if anything wrong happens. But okay, this is the connection was wrong. Although springs have gone because of the wrong connections. There was super high. Yeah, here they're getting carbonated. So do I have something more? But on this side, there's no issue. Yeah, let's just cut it. Let's have a new connection and try it again. So this experiment is gone. And it didn't transmit anything, although I shut it down. Maybe it shuts down itself after 1 minute or so. Let's see if it sends the message. Now I will try to get some new wire, which is less distorted. Crocodile clips are probably not the best thing to have a high amount of energy. And it's still not sending code, so normally, can I enable it? Yes, I can. It doesn't make any smoke anymore. That's a good thing. And it sends some data. Yep. This means that it shuts down. Oh, this is the 4. Yeah, 4 shuts down because of timeout or error. Or, yeah, timeout. It's just timeout or over 1 amp. Maybe after some time it just says over 1 amp. If I switch off, let's try again. You stay in water. The more you're in water, the better you can cool. And the water is not getting warm. Getting water warm is pretty hard. It needs a lot of energy. So let's wait until it recovers. And when it recovers, does it then send a message? Let's wait until it recovers and see if there is a second message appearing. Let me switch. No, this is something else. Here. Yep. When it recovers, it sends the message that it did recover. So the second one with the all 0 is recovered. Recovered, but only after the message. Recovered. Recovered. Sent only after activation. Now I want to try how long the activation is lasting. So let's put this on. It sends the messages. Start this. Start power. We have 1.2 amps. And we will wait for 5 minutes or so. We will see if some messages are sent. So now we know that we need to send the messages. I want to try also to figure out which of the messages we need to send. We know one of the IDs. Normally the IDs are tied to the messages, but it's if we find something with 5 FFF in the message ID, it's probably meant for the battery. Yeah, while it's running the 5 minutes, we will get the code. App data project OK firmware ESP, and then we have the network master main and Twain network master. I need to rename it, and this should be the thing with, yeah, here we have all the codes. Now we could try to figure out, do we see something with 5FF? No. What we'll do is simply disable one code after another and figure out if it's still activated. So we're still not sending messages, we're still not getting anything. There is smoke producing again on these. Why on the minus wire? I don't understand it. I'll put this. If there's only one lead in the water, it shouldn't be a problem because there should be no electrolysis, and then it cools it down. Okay, that's good. So we'll leave one probe in the water, the one which has less connection. Not ideal setup. It's hacking. Oh, I never have ideal setups, but it's good enough. So here are the codes. I would expect something which starts with 5 to be something with for the battery. So we'll start by disabling the first messages. So we're still after, we have still 3 minutes. After 5 minutes, I'll just stop. Should be enough. Oh, there's still some smoke getting produced. Where from? Oh, the heating wire is getting warm. Yes, the water is getting warm too. No, it's not okay. It was just because I was holding the heating wire. The water is not warm. 50 watts is not a lot of energy. You need 200 watts, 2000 watts or something like that to heat wire. We saw it in this experiment. No, I didn't. I didn't show it to you. So let's disable some of the battery messages. I think these ones are not for the battery. These are probably for the battery. Still wait for the 5 minutes to see if it holds. So it seems to hold as long as you want once there is a load. But my device will probably, or the motor, we never know what device will be, would take a load, switch off the load and so on, so we need to send it periodically. And we know it's valid between 30 seconds and 60 seconds. We could measure it correctly, but we don't need to. Let's wait for 1 minute, then we will flash the new code to see if the new code works. Oh, what we can do now, we'll not flash, we'll switch it off. After the 5 minutes, we'll switch it off. We'll wait 30 seconds. We'll wait 1 minute. No, 30 seconds. We'll switch it on again. Maybe it just counts after the last current draw. Almost at 5 minutes. We still can draw some energy, so yeah, I think we can draw as much energy as you want, or as long as you want it. Oh no! Oh, something else is making. This is making bubbles now. And sparks. Ooh, this is weird. but we are here. Switch it off. Oh, this is again getting completely mangled. Okay, here. Let's wait for less than 30 seconds. I think this is less than 30 seconds. Switch it on again. Is the message still valid? I have to wait more than 30 seconds. No, it's not valid anymore. Okay. So it is valid. Activation validity. Activation window. Yeah, current row validity. Valid. It's over 5 minutes if current row. Current row. And afterward, I think is still off. So the 1 minute timeout is probably still valid. So if we switch it off and the 1 minute has passed, we cannot use it anymore because I don't think we waited for more than 30 seconds. So let's wait until it recovers. Now we can send other messages and see if it works. So let's compile it. Yeah, it says deactivated. You see here, this is deactivation, switch off. So let's compile it, and now it's switched on again. So we see with the validity of the message. No, how does it work again? Ah, damn it! Now I killed it. Ah, this Python thing. I think it's backtrace decode. It's this one. Kill this process. Okay, it's killed. Now we and it doesn't give me the output, and it doesn't even show me what I'm doing. Yep, that's not what I wanted. That's also not what I wanted. This is what I wanted. Okay. Flash monitor. Okay, it is ready. Let's send the messages and see if it works. No, it didn't send. You see it's blinking. Now it sent the messages and it should be less than 29. Yeah, 24. Let's enable it. And if it holds more than 10 seconds, it means, no, it doesn't. So it's one of the first messages. So it doesn't, it could be a couple of messages. Maybe it's not all of them. But we know that it's one of them. Then we can activate the other ones, but we know that it is at least one of these. So let's try this one. Message 4. Maybe it's still a sequence of messages. I hate this pattern ID. Why doesn't it quit? I'm telling you to quit with the stupid thing. Trying to kill it. Yeah, terminated. No shit. So yeah, let's try if it's message 4. Now we sent it. Let's switch on. Okay. Maybe it's more than message 4. Let's try message 3. Maybe it's the whole. I mean, we have all. It's just out of curiosity. We can send everything. We have all the messages. It doesn't take long. I was just curious to figure out, can we identify the message? So I enabled message 3. Message sent. Let's go. No. Actually, it didn't recover yet. Okay. I have to wait a tiny bit. Now it recovered. Let's send the messages again because we don't know the validity. Messages are sent. Let's enable it. It is message 3. Is it only message 3? That would be interesting to figure out. It is definitely message 3. We don't need message 1 and 2. We don't know if we need the other ones, but at least we know we don't need message 1 and 2. Yep. So we need to wait for 1 minute for the timeout, and we have 1 minute to disable the next messages. So let's disable message. I'll leave message 4, 5, 6, 7. Let's disable these. Let's disable everything after message 4. This is drastic, probably won't work. Who knows? Flash it. So now we have only 2 messages we just sent, message 3 and message 4. I'm not sure if 30 seconds passed. We can test it, but then I have to wait for 1 minute. So let's wait for. I'll always have the seconds running. Can I actually reset the lap? Something like. Yeah. That should be more than. We have to wait for 1 minute. So let's send the messages. No. Now it sends only 2 messages. Let's switch it on. And it holds more than 1 minute. More than 10 seconds. Now the water is making some noise. This is weird. And now this one is it's making bubbles. The red one. We'll wait just for more than 30 seconds. Yeah, for more than 10 seconds it's fine. Okay. We know it's message 3 and maybe 4. Let's try with, let's reset the time for 1 minute. Let's cut off message 4. We know it's message 3 at least. Does it need message 4? Let's see. It doesn't need all the other messages, it seems. Maybe they do something else, but they don't do something for the battery. So let's wait for 1 minute. Oh, let's flash the code. Now we are only sending message 3. Okay, it is flashed. 1 minute is gone. Let's send the messages. Only one message is sent, but it has been not been acted. So let's send it again. Now it has been acted. Now let's enable it. Start the timer. Okay, just message 3 is not enough. So it's message 3 and 4. And that, let's try it again with message 3 and 4. And then we know it's both of them. And then we are done. We don't need to cut anything more out of it. We know it's 3 and 4. Okay. We have to wait until the battery recovers. It's at 26 volts. It's not recovered. Takes 1 minute, the same as the timeout for the activation. So this is kind of a pain because it means that if I want to use the battery, I'll always need to periodically send a message. So we need a microcontroller with CAN, and one other issue is that this can output some energy for the microcontroller, but it's above 30 volts, and most LDOs or switch mode power supply don't do that. So I need to develop or design something which can take up to 60 volts, step it down for the microcontroller, so the microcontroller can always be activated, because I don't want to have an external power supply or battery connected all the time to it to send the messages, since we have power here. So I need to design this and need to find a kind of, a step down converter which is capable of handling 60 volts, which is rare. So let's send the codes. Codes are sent. Let's enable it. Let's switch on. And if it holds more than 30 seconds, we know it's message 3 and 4. We tried without message 3, without message 4. Individually, it didn't work. Yeah, it's message 3 and 4. With both it worked. With just one less, it didn't work. And we need to send them periodically at least every minute. Yeah, more than 30 seconds, it's still on. Okay, this is done. Now I need to design a microcontroller board which connects to it, accepts 60 volts, and sends these two messages every 30 seconds. Let's making every 10 seconds so that we are sure, or every second. I mean, there's nothing else on the CAN bus. We can send it constantly, but we know we need that. And yeah, with that, I think this hacking is done. I'll probably show you once I get the board designed and once I get the board produced. There's nothing. I'll use the same microcontroller. Oh, let's switch it off. Okay, it will be the same microcontroller because I have the code for it and it's not expensive. It's an ESP32C3. I could use an S2DC3. It's just not expensive. I think around $105. There will be a CAN module, 3.3 compatible. There will be a step-down converter to 5 volts because the CAN module needs 5 volts. The ESP needs 3.3 volts, so there will be an LDO after the step-down. And that's basically it. There will be an external flash if you don't use embedded flash, but that's it, one LED. And something which fits on the back here. This will be a bit harder. Although no, I can make it go above and below. I have space. I don't need to be constrained on this thing. Well, let's see. I'll design afterwards. But we know now that to use this battery for with more than 1 ampere, you need to send CAN messages constantly. Well, at least more than every minute. And we know the two messages. Well, you saw them on screen. Messages 3 and 4 will only send these. I'll document it and I'll let you know once I've made the board. I still don't know what I'll use the battery for, but at least we continued to figure it out, and it was fun to hack this. Okay, well, with that, enjoy the rest of the evening. Bye bye.